Okay, so number 12 on this sheet, it will appear under homework is graph y equals 2 to the x. Well, here's your graph. Here's where x equals 1, here's where x equals 2, here's -1, here's -2, here's 1 on the y-axis. So here's 2, 3, 4 is up there somewhere. Not a particularly well-drawn graph, but closer than some I see, okay? And it's okay. Although I would prefer to see the table and for you to label the points that you graph, okay? Then you're more likely to be accurate. So if it's terribly inaccurate because you didn't do that, as long as you do everything else, you get substantial credit, but you're going to lose some too. Okay? I want reasonably accurate graphs, hand sketch. Then the equation solve approximately using the graph equation. This says 2 to the x equals 2 plus a over 10. Now let's use a reasonable number for a, because if I use that name over there, we're going to go off the limits of the graph. You got a very long first name, maybe you'll go a little bit beyond x equals 2. For me, my a is 5 over 10, which is 2.5, right? So that's very easy. Just copy down what it says and do it. Then what do? You want to find the x value that gives you y equals 2.5. And the question is, y equals 2 to the x equals 2.5 for what value of x, right? So you go up here to 2.5, come over to the graph, come down here, and you say, okay, x is 1.4. Right? That's a bad estimate because 1.2 to the 1.4 actually, it's not too bad of an estimate. Actually, a fairly good estimate. I'm proud. Okay, you proud of me? Somebody give me a little. Okay.
I can't dispute it.
I just got a warm feeling inside. Now, okay, we got it? And, you know, that should be instantaneous. We've been doing that again for a month and a half. Okay? One of the things I tried to establish really early, how you use the graph to do estimates and how you can use that to solve an equation. I didn't say earlier we're solving this equation using this graph, so that this terminology is a little bit new, but it's the same thing that you've been doing. I'd say estimate the x value of y equals this, estimate the y value of x equals that, right? And that's all we're asking you to do. Okay, let's see. Anything else we've got to say? Yeah, the rest of these problems are pretty much just problems that I would regard as pretty straightforward with nothing new, except maybe for the last one. We did that a long time ago, so let's just real quick look at that last problem. I'm going to squeeze it in here. Okay, it's a backward apostrophe A, backward apostrophe B again. Okay, if the graph of this thing goes through these 2 points, then y equals a times b to the 4th. Would you agree? Because when x equals 5, b to the 5th, when x equals 5, y is supposed to equal 4, right? Well, if this is the function and x equals 5, then you're going to have b to the x, b to the fifth, and y then is going to be 4, right? And then also, you have 6 equals a times b to the 0. So you have two simultaneous equations that you can easily solve for a and b. Matter of fact, they're really easy since I gave you 0 here. What's b to the 0? 1, so what's a? Yeah, a times 1 is 6, so a is 6, right? So now you plug 6 in here, and now b to the fifth equals 4 over 6. Take the 1/5 power of both sides, and you've solved it. Now again, that's an equation solving technique that not everybody is completely attuned to, so you want to be careful about that. The other thing is, you got denominators, multiply by the common denominator. I'm seeing way too many people try to solve equations that they're probably never going to be able to solve unless they do that, okay? Because they're very complicated if you don't multiply out your denominators. And they become very simple. Every such equation is probably going to become either linear or quadratic equation, and it's going to be easy to solve. You keep those denominators in there with the variables, you're going to get messed up, or you're going to take a lot longer than you need to take. Okay? Make sense? Yeah, I've been harping on that for a long time. Try to lock that in. Okay.